everybody, Mrs. Wagner here. This instructional video is going over the physical and chemical properties of matter answer doc that goes with the reading packet that you guys were working on in the last couple of days. So we're going to go over all of the answers, and as you watch this video, if you split screen the video with your document, you can compare your answers with what I'm going to share with you. And if you haven't gotten them all done, go ahead and just fill in what you need as I, talk about what physical and chemical properties of matter are. Okay. All right. Number one. So what are physical properties of matter? So there is a difference between physical properties and chemical properties. Physical properties are just properties that we observe that do not change the identity of the substance. So physical properties are properties that we observe that do not change the identity of a substance. Meaning, if we're going to observe something like malleability, which is the ability to bend or be rolled into sheets. If I change the shape and bend aluminum foil, it's still aluminum foil. So I'm observing that it's malleable, but I'm not changing its identity as I observe that. Okay, so any physical property that we can observe does not change what the substance is. Another example would be gold. If we melt gold, we are observing its melting point, which is a physical property, but by melting it, all we're doing is changing its state of matter. We're not changing its identity. It's still gold. It's just now liquid gold. That's it. Okay. All right. Number two, when we observe and measure physical properties of matter, does the identity of the substance change? The answer is no. So I just explained the gold situation along with the being able to bend aluminum foil, and it's still aluminum foil. Okay. So give an example. You could use the gold example that I just gave or the aluminum foil example, or on page 23 of the packet. It did have some more examples. And I've lost internet. Okay, hopefully I'm still on. All right, I lost internet there for a sec. Okay, so I'm just going to type in here one example. Come on, computer. Is, as it keeps typing here. All right, one example is if we melt gold, we are observing the melting point but the gold still remains gold. Okay, so what are three physical properties of gold? Okay, you could say that it is shiny. You could say that it's a soft metal. Okay, it is able to be shaped, so ability to be shaped. We have lots of gold pieces of jewelry, the different shapes of jewelry, statues, and things like that made out of gold. Okay, here's a picture of oil and vinegar. The top layer is oil and the bottom layer is vinegar. Compare the density of the vinegar to the density of the oil. Okay, so if the top layer is oil and the bottom layer is vinegar, that means the vinegar is more dense than the oil. And then when you guys did your density columns, we saw that oil did float above most of the substances that we put in the density column. So oil does not have a very high density. Okay. All right. Density is a physical property. We can observe density of an object or a substance, and we don't change the substance while we're observing it. Okay. 5, if you add Kool-Aid powder into a pitcher of water and stir, then you let all of the water evaporate out of the pitcher. Would you be able to see the solid particles in the drink mix? And the answer is yes, because the powder, say the Kool-Aid powder, does not evaporate with the water. So only the water particles are evaporating. Okay. Now some of the Kool-Aid particles might get suspended up with the water particles just because they're so light, but they don't evaporate. They don't change their state. They're just kind of getting lifted with the molecules. And eventually they'll fall back down. But most of the Kool-Aid powder will still remain in the left into the cup. Okay. Okay. All right. So let's look at what is malleability. All right. So malleability, that's the ability to be able to be rolled into sheets, or we could say even bent easily. Okay. All right, number 8, what are all of the physical properties described on pages 24 and 25? Okay, I'm seeing density. I'm seeing electrical conductivity and thermal conductivity, solubility, which is the whole Kool-Aid mix property there, okay? That Kool-Aid will dissolve in water, okay? All right, what else do we have? Malleability and magnetism. So you guys did some tests with magnets to see if your substance was magnetic. So magnetism is a physical property. Let's see. Luster. That's if something is shiny. It has luster. Okay, boiling point, melting point. And let's see, that might be it. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many I have? Okay, I hope that's all of them. I know you might be screaming at the screen if I don't have them all or miss them. Okay, let's see. Next one, chemical properties. Okay, so chemical properties are a little bit different. These are properties of matter that, when they're observed, it does change the identity of the substance. So chemical properties are properties of matter that change the identity of the matter. Okay, so if you burn something, flammability is a chemical property. If you burn something, it no longer is the substance you originally had. You know, if you burn paper, it's not paper anymore. It doesn't look like paper, doesn't have the same properties of paper. You just kind of have a pile of ash, water, and then you see some smoke. So those are completely different substances after you burn it. And so that's what chemical properties are. Common chemical properties of matter. We're going to talk about flammability and reactivity today. Okay, so a lot of things can go under reactivity that we'll talk about later, but let's get into just what that particular word means first. Okay, so number 11, why is rusting a chemical property of iron? So you see like a nail that's been placed in water or is left outside and gets wet, and then when it dries, you see all of the rust kind of laying around that iron nail or just on the iron nail. So what's going on there? Why is rusting a chemical property of iron? Well, the rust wasn't there before. So the iron reacted with the oxygen in the water and became rust. Okay, so rusting is causing the iron nail to become something new. We call that rust. Okay, there we go. Okay, so why do automobiles rust more easily in wet climates than drier climates? So in wet climates, so iron rusts more easily in wet climates because we need water for this to happen. So there's more water in wetter climates. Okay, this allows for more oxygen to come into contact with the metal to make it rust. Okay, number 15, since gold does not burn, it does or does not have the chemical property to burn. So we can test for flammability on gold. So we can walk up to gold with a lit match. We can put it under a lit match or put a match under the gold and see if it burns. We are trying to observe the flammability of gold, and we are seeing that it does not burn, okay? So it does not have the chemical property to burn since it's not changing the gold into something new. Okay, it makes it hot, makes it warm. We can observe the thermal conductivity and we can say, oh, it's warm when I apply thermal energy to it. So it's got thermal conductivity as a physical property, but it does not have a chemical property of flammability. Okay? Okay. What is the difference between physical and chemical properties? So let's go back to what we just learned about physical properties. They do not change the substance when we observe them, but chemical properties do. So physical properties do not change the identity of a substance, but the chemical properties do. All right. Okay, about halfway done. What type of property is being shown by each nail? Okay, so bending, we learned that that's a malleability property, the property of malleability, and that's physical. So we'll say physical property, and it's malleability. Okay, how about the iron nail becoming rusty? So we're actually changing the iron in having it become something new. Rust, which wasn't there before. So that is chemical property, and that would be reactivity. Okay. All right. Number 18. Bring this up a little. Oh, where'd that picture just go? Oh, well. Okay. So number 18, highlight the correct type of property to show whether each property of an iron nail is a physical or a chemical property. So an iron nail has all of these properties. Are they physical or are they chemical? So malleability, we've already stated that's physical. So we can bend the nail. We could kind of hammer out the nail and change its shape, but it's still a nail and it's still an iron nail. When it reacts with oxygen, that's a chemical one because it's changing into rust. It's a new substance now. Magnetic, okay, it has the ability to be attracted to a magnet, but it's still an iron nail when we observe that. So that would be a physical property. Non-flammable, we can take lit match and observe flammability and see that it is not flammable, but that particular property would still be considered chemical. We're not changing the nail, okay? Can't burn a nail, but we're observing the property, and that's kind of the important part. Even if you just observe the property, you still have to put it in the right category. So we're observing flammability, and that's a chemical property. Just because it doesn't have the property doesn't mean it's not a chemical property. It just doesn't have that chemical property. Ooh, coffee's done. Okay, number 19. What happens to gold when it's hit with a hammer? Okay, so we're going to hit gold with a hammer. What happens to it? Gold will flatten. Okay, so what happens to the iron pyrite? Iron pyrite will shatter. Come on. There we go. Iron pyrite will shatter. Okay, different than what's going to happen with gold. So gold is malleable, iron pyrite is not, does not have that physical property. What color streak does gold leave? Let's see. Gold. All right, gold will leave a yellow streak, and iron pyrite will leave a greenish black streak. So when you guys did the mineral identification gizmo, you did virtually, digitally take certain minerals and you did a streak test. And you saw that some substances left a white streak and some didn't leave any streak at all. So yes, in trying to identify a substance, they do streak tests to see what color of a mark it's going to leave that helps them identify what the substance is. So which property of matter will tell miners if they have gold or iron pyrite? They could do a streak test, but density is really going to be the one that determines whether what we have is gold or iron pyrite. Okay, so a student finds an object with a mass of 65.54 grams and a volume of 14 cubic centimeters. Find the density of the object. Okay, we've learned that mass divided by volume is the density formula. So the mass, if you're going to put this into a calculator, you type that in first. So its mass is 65.54. And the volume, so you do 65.54, you hit the divide sign, and then you enter in 14, and then the answer is 4.61 grams per cubic centimeters. So the density of the object is 4.61 grams per cubic centimeters. So to do the little 3, you're going to go up to Format, Text, and Superscript. Type in your 3 to get out of it because you don't want it to stay up there. Go back to Format, Text, Superscript, and you get out of it. Okay, so gold's density is 19.3 grams per centimeters. Could the object be gold? And the answer is no. It doesn't have the same density. All right, so choose the correct answer by highlighting it. Solubility or flammability is a physical property. Solubility is a physical property. The melting point of a substance is the temperature at which the substance changes from a solid to a gas or a solid to a liquid. So going from solid to a gas or a solid to a liquid. Well, melting, we're taking something like ice and we're going to melt it. It's going to become water, which is a liquid. Reactivity with water or magnetism is a chemical property. And when something reacts with water, either like rust or our iron nail becoming rust, or something that would be a little bit more explosive, because there are some things that react with water that have a more violent type of reaction. That would be a chemical property. Okay, flammability is the ability of a substance to transfer heat or burn. And well, it's burn. We know that. Okay. The characteristic properties do or do not depend on the size of the sample. And honestly, they do not. So you could have a small piece of aluminum foil. You could have a large piece of aluminum foil. they still have the same properties. They're still going to have the same density. We learned that in the cylinder lab. Didn't matter what size the cylinder was, each of them had the same density. You can still bend it, whether it's a small piece or a big piece. It still has luster. It still has all the same properties. It doesn't matter what size it is. All right, lesson review. We are at the end here. So flammability is an example of a chemical property. Electrical conductivity is an example of a physical property. What are 3 physical properties of aluminum foil? So we've really talked about that a lot. Malleability, luster. It could be a third one. Okay, we could also say it's a solid at room temperature. All right, and maybe you had some other physical properties of aluminum foil. Okay, we know it's not magnetic. It has a low density. We do know that. All right, what effect does observing a substance physical properties have on the substance? No effect at all. Okay? It doesn't change the substance into something new. Okay, describe how a physical property such as mass or texture can change without causing a change in the substance. Okay, so we can divide a substance in half without changing the substance. Okay? It may change the size or the mass of it, but not the identity. Okay? Must a new substance be formed when you observe a chemical property? All right, so if you're observing the chemical property happening, then yes. Okay? Because it's not a chemical property if you don't. So chemical properties do change the identity of a substance and causes it to become something new. Okay, suppose you need to build a raft to cross a fast-moving river. Describe the physical and chemical properties of the raft that you would want it to have. I'm going to say not soluble. I do not want it dissolving in water, obviously. Okay. I would also want it to be less dense than water. We don't want it to sink. Okay. I wouldn't want it to burn. I mean, you got water around you, but you can still burn a boat. So, okay. I wouldn't want it to bend or break. So not too malleable. I would want it to be a strong substance to hold up. Okay. Oh, would we want it to react with water? No. So I wouldn't want it to be reactive with water. Not reactive with water. Okay. Maybe you included some other things too, but those are some really good things you would want your boat to either have or not have if you want to get across a fast-moving river. Okay. All right. That's it. You will have an assignment posted on Google Classroom to work on after this, but make sure you get this done and turned in. We'll see you later. Hope you're having a good week.